Hello and welcome to this Azure Back to School session for 2025. My session is building a cloud-centric network with Azure Virtual WAN. I'm Jake Walsh. I'm over on X at JakeWalsh90 and over on jakewalsh.co.uk where I do a little bit of blogging and writing of articles. Lucky enough to be a current Microsoft MVP and also a HashiCorp ambassador. Hopefully for reasons that you'll see throughout this session. But yeah, hope you find this useful. As always, the usual disclaimers apply. My own opinions. Please do check latest documentation and that sort of stuff. So let's get started. So I actually first participated in Azure Back to School. I think it was last year, and for 2025, I'm looking at Virtual WAN again. But there are loads of amazing sessions, a huge range of all different sessions focused on different topics, different areas, and just a massive thank you to the Azure Back to School team for putting the event together. It really is appreciated. So for those of you that saw my session back in 2024, you're probably thinking, why am I doing the same session again? What's the method in my approach here? And back in 2024, I ran through Azure Virtual WAN in detail. I went through all of the core components. I talked about use cases. I talked about security. I'm not going to repeat that for this session. What I am going to do is cover off a couple of the changes, a quick recap on some of the core components, and then I'm going to talk predominantly in this session about some of the infrastructure as code deployment options. So in particular, I'll be covering Terraform, as that's kind of my area of focus. If you do want to see the full session where I go through Azure Virtual WAN, scan the QR code or just visit that link down on the bottom left there, and you can get access to the YouTube video, my blog post to accompany it, and all of the information that goes with that. So what are we going to cover in this session? Well, we'll look at the changes that have happened to Virtual WAN since I last did the session. We'll recap the core components, and then I'm going to take you through some IAC deployment options, just using Terraform, and show you a demo lab environment that I use just to get things up and running, and allow you to sort of get started with Virtual WAN, test things out, learn a bit more about the Terraform deployment, and really just get comfortable with that approach, as well as sharing some resources and things like that that'll help along the way. Okay, so it's worth just covering that Virtual WAN is always improving. There are lots of changes that have happened over the last year, and perhaps one of the biggest ones is route maps. So route maps is a feature that gives you the ability to control route advertisement and routing for Virtual WAN virtual hubs. So think of that in perhaps more complex network environments where you need to control those advertisements, you need more control, that sort of stuff. This is quite a big change for those with those types of networks. So if you do have any need for that, just check out the Virtual WAN page on Microsoft Learn. You'll be able to see all the latest information on that feature. Worth also calling out that that's not the only thing that's changed. So you'll see here, April 25, February 25. There's been quite a few different tweaks, changes that have come along the way. Perhaps, if we just run through these, so network virtual appliances / NVAs, integrated third-party solutions in Virtual WAN hubs can now have additional IP addresses, both internal and external interfaces of NVA. So it gives you a bit more flexibility and addresses some of those concerns related to SNAP port exhaustion. Also, some of the reimage options as well. So reimage existing NVA deployments, to a base unconfigured image from the Azure Marketplace. So again, perhaps useful for security or changing versions or that sort of stuff. Another one, so Versa for their network virtual appliances. General availability in February 25. So that applies to you, something worth checking out. Also in February 2025, so general availability of Cisco Firepower Threat Defense in your Virtual WAN hub. So again, a few different releases that have happened, since I last gave this presentation. But just as by way of a bit of an update, hopefully that just gives you an idea of the things that have changed in the last year. Okay, so moving on, we're just going to have a look at the core components again. I think it's important just to provide that context, provide that grounding, before we start diving into the infrastructure as code aspects. So when we talk about core components for Virtual WAN, what we're actually talking about really is 5 key components that are kind of the backbone of Virtual WAN, the core things that you would deploy. And it's worth just calling out, this is really in any deployment that spans more than one Azure region. If you were deploying, for example, just in a single region, perhaps you wouldn't have that hub-to-hub connection. Perhaps you would just have an isolated instance, but predominantly, Virtual WAN is used in quite large deployments, so you would typically have all 5 of these aspects. Okay, so the first is Virtual WAN itself, and this is a virtual overlay of your Azure networking. It's a collection of multiple resources, kind of bringing all of those resources together, and it contains all of the Virtual WAN components in your topology. And when I switch to my lab environment shortly, you'll see this just whilst I sort of show you what that looks like. And really, this is kind of a container resource. So once you go into this, you'll see all the other resources that sit within it. And that's things like, we've got ExpressRoute, site-to-site VPN, perhaps point-to-site VPN for dial-in users, hub-to-hub connections, VNet connections, and that sort of stuff. The next aspect is a hub. So the hub is a Microsoft managed virtual network. We're probably all used to that hub spoke topology that we've seen in environments. Well, this replaces the hub in that, but it's managed by Microsoft. You don't have to go off and build this manually yourself. It's done within Virtual WAN. So the hub is the core of the Virtual WAN network. Typically one hub per region. It could be more if you were doing a perhaps more complex environment with multiple virtual WANs, that sort of stuff. But typically you'd have one per Azure region. Your gateways for things like VPNs, ExpressRoute, point-to-site, all of that sort of stuff is deployed within that hub. And any firewalls or NVAs you would like to have are also typically deployed inside of that hub as well. There's also an important consideration around routing units, and that's how Virtual WAN scales. So you would need to consider how many routing units are needed in your hub to make sure that Virtual WAN can accommodate the traffic within your topology. Okay, so let's just break that down a little bit. What's in hub? I know I kind of went through that in the last slide a little bit more, but when we actually look into a typical hub that's deployed perhaps in an enterprise organization, we would see usually a mixture or all of the following items. So a virtual network gateway for terminating those point-to-site, perhaps those IPsec tunnels, things like ExpressRoute gateway, I've touched on point-to-site already, of course, but things like Azure Firewall, the NVAs, perhaps you have Azure Firewall deployed, perhaps you have a third-party NVA solution. Those are the things we would see inside of that Virtual WAN hub, bringing all of that networking configuration, all of those elements together in that single point of control. We'd also see route tables, so controlling the routing within our topology. Those are assigned and attached within that Virtual WAN hub. And finally, we'd see that hub-to-hub connection, so building that topology out globally. And those hubs connecting, that's where we'd see that connection. And again, when we get to the lab environment, I'll go into that in a bit more detail and just show you what that looks like. So hub-to-hub connection is an important point to remember. Now with hub and spoke, we would have to manually connect our hubs together. In Virtual WAN, hubs are automatically connected. So they're automatically connected, they can communicate freely, and the routing is propagated throughout. So if you deploy three Virtual WAN hubs as part of your Virtual WAN deployment, all of those hubs will automatically be connected. They will have connections, they will be able to communicate, and that route table is managed for you. Inter-region connectivity. So for example, imagine perhaps the VNet on the left, the very left of the diagram here, connecting to the VNet on the very right, would happen through those Virtual WAN hubs. That's important just to point out as well, connectivity controlled using a firewall or an NVA. And previously, this is something I encounter sometimes when I speak to people about Virtual WAN. There were some limitations around inter-region communication, particularly with control in a firewall. With the introduction of routing intent, that's no longer the case. So you can have that full control of all of that topology. Now that hub virtual network connection is effectively our replacement for hub spoke that we would have had previously. It connects those VNets into a hub, and in each deployment, a virtual network is connected to a single Virtual WAN hub. That then allows traffic to flow through those spokes, connecting the spokes together through the hub, connecting spokes in disparate regions together through the hubs, and we can obviously use Azure Firewall or another NVA to control that traffic. Now, the hub route table is an interesting one in Virtual WAN, because this, for me, I think is one of the biggest strengths and perhaps one of the biggest reasons to adopt something like Virtual WAN. So each hub has its own default route table. Now, we can add static routes to that if we need to, and those take precedence over the dynamic routes. That route table is associated with its hub and also associated with the virtual networks connected to that hub as well. Now, connections like things like VPN, ExpressRoute, point-to-site, they also have a routing configuration that propagates to a route table. So, for example, we can control perhaps dial-in users and how their traffic is routed when it comes into that hub. We can also use labels to logically group route tables, so perhaps in a more complex environment. Yeah, there's a whole range of control aspects we can utilize for that. Now, it's worth calling out this has been a very short kind of whistle-stop tour of a hub route table. Do have a look at the link on the screen there, because that will give you some more information. It'll give you some more guidance, and it just makes it a, breaks it down in a lot more detail and a lot more thoroughly than I have in this quick session here. So another question we're often faced with when sort of asked about why would I go virtual WAN over a traditional hub and spoke is this. So where does this compare? How does it compete? What are the differences? So a virtual WAN would replace typically a hub and spoke architecture. Think of that virtual WAN hub as a replacement for the hub we would have deployed previously, and those spokes are, there are spoke VNets and they're connected into that virtual WAN hub. Now, those hubs, as I said, were fully managed by virtual WAN, so we don't have to sort of control them. We don't have to, manage those. Virtual WAN picks that up as part of its wider sort of topology control and as its centralized resource. All of the spokes peer into those hubs, and then spoke to spoke traffic goes via the hubs themselves. So really, what we're doing is centralizing this connectivity and just allowing that central point of control. So that was a very whistle-stop tour. As I say, if you do want to see the more comprehensive overview, you can look at last year's session that I put a link to just at the beginning, and I go through that in a bit more detail, break it down, and just have a look at a few more details. What I'm now going to do is just switch to looking at the Terraform deployment and running through how I deploy virtual WAN using Terraform. So bear with me a second. I'll just switch my screen. Okay, so what we have here is my code for deploying virtual WAN in Terraform. And I'm just going to spend a few minutes just running through this code, running through the sections, running through everything there is. Now, I should point out when I get to the end of this, you don't need to take notes and type this all back out yourself. This is actually downloadable from my GitHub repo, so I'll share that. I'll share that with you in a second. What we actually have here is a Terraform deployment, just some TF files you can see here, that goes off and deploys virtual WAN in 2 regions and deploys a number of virtual machines just for testing purposes. And interestingly, in this environment, I've popped Azure Bastion in so that we can remotely connect to those virtual machines just to do some ping tests and things like that, just to prove that the virtual WAN topology is working, to prove things like firewall rules are working. And it just gives you an environment where you can demonstrate that and you can play around a little bit and just get familiar with, that deployment. Just one point to make before we get into this: virtual WAN does incur some cost. So if you are deploying this in a lab environment, I would recommend you just look at and understand the cost before you go ahead and do it. Don't want anyone running up a large bill or anything like that. So we start in the most basic area, perhaps just creating here just 2 resource groups. So you can see I've got a region 1 and region 2 resource group, just so I've got 2 resource groups to deploy virtual WAN into. If we then go into the virtual WAN deployment, you'll see initially I'm just creating virtual WAN. So I only need a single resource to do that. One virtual WAN. It's not deployed in both of those regions. It's only the hubs we have in each of the regions. Moving on, you'll then see line 15 down to 38, just these 2. Here we have both of the hubs, so a hub in region 1 and a hub in region 2. We also then connect those hubs together. So that's important. We just need to create that virtual WAN hub connection, and all we're doing there is telling that virtual hub that it's connecting to the other hub. So you'll see here region 1 connection, so region 1 VNet to virtual WAN hub. So what I'm doing there is just connecting in the remote virtual network. So you'll see I've got a VNet in region A and a VNet in region B, and I'm just connecting those into the hubs. It's worth just calling out those hubs are automatically connected once they're part of that virtual WAN topology, but I do need to tell those VNets that they need to be connected into their respective hubs. And you'll see when I go up here, so if I just go to networks.tf, scroll that up, you'll see I've got a VNet in region 1 and a VNet in region 2, and these were the VNets that were referred to here. just highlight that for you. So those are what I'm connecting into those two hubs. So the VNets are connected to their respective hubs. Within the networks file, just coming back to that, you see I've got a few things going on here. So I'm building out the VNets, I'm building out the subnets. So I've got just a basic subnet and one for Azure Bastion as well, the same in region 2. And I've just got a couple of NSGs that basically allow RDP inbound for that testing purpose. Obviously, this is a bit different to what you would perhaps deploy in a production environment. Just moving on, I've also got key vaults. So I'm actually using a key vault configuration that I've shamelessly stolen from another deployment I wrote, and this just uses the random aspect within Terraform. So it uses the random provider just to generate some random IDs, so that when I do store the password down here, and this is the password used to get onto those virtual machines, you could go and deploy this lots of different times, and in theory you would have a completely randomized password each time, just to make sure, if you are deploying this en masse or several times, there's a bit of security built in there from the outset. Coming back to something that's probably one of the more basic things I've done in Terraform here. So I have Azure Bastion deployed. There's not a huge amount to go through in this section. Got a public IP for Bastion in each region, and then just a Bastion deployment that you can see in this section down here. Okay, so moving on from Azure Bastion, we also have Azure Firewall deployed. Now, in this particular deployment, I'm actually using a count variable. And you'll see here the count variable is listed against all of the resources for Azure Firewall. And the reason for that is when I was building this lab environment, not everybody that was using it wanted Azure Firewall as part of it. So if I just go to the variables.tf file, what you'll see if I just scroll down and find it, so we have an optional resources section. And this actually allows us to set whether the Azure Firewall is created or not. So you can actually turn that feature on or off depending on the deployment you want to test, depending on your particular use case. And if I go to the tf-vars file, you'll see if I have that set to true, it will deploy the firewalls. And as a result, it will also deploy the subsequent resources. So we've got firewall in region 1, firewall in region 2, the policy, and so on and so forth. So you can turn that on and off depending on your particular use case, depending on your particular needs, but it's just there in case, perhaps you just want to test virtual WAN, you're already comfortable with Azure Firewall, you can turn that off so you're not incurring that cost. And then finally, it's just the virtual machines really. So if I just scroll this back up to the top, I'm just creating two virtual machines. So the first is I'm creating the network cards and the public IPs, and then just creating some basic VMs for the testing purposes. Really just something I can log into via Bastion, jump onto, prove ping connectivity, test RDP, that sort of stuff, and just prove that those machines are communicating across that virtual WAN topology. I have some basic setup scripts that run. You're welcome to go into this and just have a look, and obviously welcome to download a copy and tweak this as you see fit. But hopefully that just gives you an idea of the code required to do a sort of basic virtual WAN or virtual WAN testing deployment. I'll just switch back to PowerPoint now. So that was a quick overview of the Terraform deployment. What I'd like to just quickly share now is if you do want to download a copy of that environment, as I said, you don't need to rapidly take notes and draw it out as you need to. Just scan this QR code or just go to JWalsh90 on GitHub, sorry, and you'll be able to download a copy of that you can use as required for your own testing. It's worth calling out as well. I've been kind of modifying this and working with it over a couple of years now. So if you do have any issues, any challenges, feel free to raise an issue. I can't promise it'll be fixed immediately, but certainly I do like to try and keep these up to date so they're there if needed. Okay, so let's just have a quick look at what that actually deploys. So bear with me a second. I'm just going to switch across to Microsoft Azure. Okay, so hopefully you are seeing the Azure portal now. So this is actually the subscription I've deployed Virtual WAN into, and you'll see it's actually built out quite a large number of resources for us. So I'm not going to go through all of these. I'm sure you know what a virtual machine is. I'm sure most of us have seen an NSG or a network interface. I won't be going through all of that. But what I do want to go through is the particular Virtual WAN deployment as well. So let's just go into that. Okay, so what you can see here is what the kind of landing page, the initial page for a virtual WAN deployment looks like. And you'll see here on this globe diagram on this map, I have 2 hubs deployed. So I have an East US deployment, and you'll see here I don't have any VPN sites or express route or anything like that, but what I do have is Azure Firewall deployed, and it's the same when I click on UK South. So if you're working on it in a a large environment where you've got multiple regions deployed, a large global network, this is really useful because it gives you that sort of overview of where you have your deployments. If I click here into hubs, what we'll see is we have 2 hubs deployed, their address space, where they're deployed, and so on and so forth. I can click into one of those. And what I actually then see is I can see what else has been deployed as part of this. So as I said, I only have some virtual network connections and I only have Azure Firewall deployed. But if I wanted to deploy a site-to-site VPN or an express route, for example, I can just hit create and it will take me through that process. This is kind of a guided experience. So it makes it very straightforward for any future deployment. If I go into Azure Firewall, what you'll see here is a firewall policy applied. So it tells me the firewall resource and it also tells me the policy that is assigned to that virtual WAN hub. Now you'll see that's FW Polo 1. If I go back here to the hubs and go to East US and then look at firewall, what you'll also see is I have FW Polo 1 as well. So what's really nice about this is I have all of that control centralized. I'm just using a single policy for testing. It's all very straightforward, very easy to manage, and it's not hugely complex with lots of different areas that I need to go in and control. If we want to look at those firewalls, we can click into that and it will show us the relevant Azure firewall. We can see all of the areas. We can see all of the configurations. So I can look at all of the aspects I would need to manage as part of that firewall. Now, if I come back to hubs here, you'll see as well, I have the virtual network connections. Now, this just takes a moment to refresh. Okay, there we go. So I can actually see each of the hubs listed. I can see the regions they're deployed in, and I can see the networks that are connected to them. So if you're just trying to troubleshoot an issue or trying to find out some information, this is really useful as well. Getting everything in that one place where you can go and find out which networks are connected to your to each of your Azure Virtual WAN hubs. I can also look at the routing configuration as well. So I can click in here, I can see what's going on there. I can look at the default route tables. I can perhaps make changes as I need. Again, really, really useful for that control. We also get a nice overview down here of the hubs. So I can see those hubs. I can look at any remote VPN sites. Again, really useful if you have multiple sites and need to see where they're connected to. Perhaps you need to know which hub, perhaps you need to know where they are. Again, seeing all of that in a single centralized administrative point is really, really useful. Again, user VPN configurations. If we had a dial-in point-to-site VPN here, again, it would show up and we can control and manage that from this central location. It's worth calling out as well that all of the Azure Monitor aspects, so we can start using things like Connection Monitor, we can start using things like Insights to get all of the information we need, on our topology and on our deployment. You'll see here, this is a nice little breakdown just to show what's connected and how it all fits together. Very, very useful when you're learning and testing, and then very useful when you're managing virtual WAN in its deployment. Just a couple of things as well to talk about in terms of the demo lab. So that particular Terraform environment that I talked about does deploy Azure Bastion, does deploy 2 virtual machines. So you'll see there's Bastion in East US, a virtual machine in East US, and Bastion in UK South, and surprise, surprise, a virtual machine in UK South as well. What that allows you to do is actually connect into those machines independent of the virtual WAN configuration. Now, I know that's perhaps a little bit non-standard. You probably wouldn't operate like that in production. You might centralize Bastion or have a different way of connecting to them. But what this does allow for demo and testing purposes is you to get onto those virtual machines and then do connection tests, ping tests, all of that sort of stuff over that virtual WAN topology. So designed for testing, this is not designed as a production environment. Just a couple of other things to call out as well as part of this session. Just switch across here. Terraform environment I mentioned, so you can go into GitHub, you can view that, you can download it. What I do actually have in here as well is just an overview of what's deployed. So you'll see in this diagram, this is the without firewall option, but it shows you how everything is tied together on all of the things that you would need to go off and learn and then deploy virtual WAN using Terraform. Pretty much the same with firewall. Obviously, you'll see the firewall's just dropped in there as a point of control, and this just explains how you would do that. So again, if you have any issues with this, just refer to this and and go from there. Right, I shall just switch back to PowerPoint now. Okay, so just to wrap a few things up, finally, I have written quite extensively about using Terraform with Virtual WAN. A couple of blog posts on the left, one from June 2025. I spent quite a while talking about Virtual WAN, attended a couple of user group sessions. So if you do want a bit of an update, a bit of a recap, perhaps you watched last year's session, and you want to just dive into some of those changes, just scan that QR code, it'll take you straight there. And previously, back in 2022, I wrote about deploying Virtual WAN using Terraform. So if you'd like perhaps a more comprehensive written article, again, scan that QR code on the right, and it'll take you through all of that information. Finally, just a thank you. So I hope that's been useful. I hope you find the lab environment helpful. But yeah, thanks to the Azure Back to School team. Thank you to everybody else that's participated. I hope it's useful for you. And if you have any questions, you know where to find me. Please do reach out. I'm always happy to help as best I can. Thank you.